All right. Hello, welcome. This lesson will be going over encryption, just kind of the very, very basics of it, encryption and decryption. And where really relevant in the world of computers is we have data that we don't want other people to be able to see, especially on the internet. So what happens is it gets encrypted. So the idea is like if I'm logging into my bank account here, like let's say my account number for my bank account is 1234 or something like that, then the idea of encryption is you change it somehow. So it's this is what's called the plain text, the actual text, and then you encrypt it into something else. So like a really stupid version of this would be like if you just reversed it 4321 and then sent that bank account through the internet, and then on the other end, my bank would have to decrypt it, turn it back into the plain text, reverse it again, and so then I could log into my account. So the idea is you change it to some different version so other people can't tell what it is. And obviously that's like a really super simple and stupid one. But it's kind of interesting because this is something that's mattered forever, right? Like when I first read about this way back in the day, like generals would be trying to like send information to each other, like even before the days of computers and a lot of technology, like even back in like the Roman days, they would write it on pieces of paper and send it with a carrier to like another general or something, but they'd have to encrypt it, right? They'd have to like write it in some sort of pattern or algorithm so that other people, if they captured the messenger, they wouldn't know what the message said. Okay, so like there's lots of times where you can see some examples up here of where you'd want to encrypt your data, and kind of a really cool example is this is taken from the movie The Enigma Machine, but that was the German code. The Nazis in World War II, for sending their messages, they had this special machine called the Enigma, and this guy Alan Turing broke the code. And this is kind of from the end of the movie, but him breaking this code, they think shortened the war by more than 2 years, saving over 14 million lives. So it's kind of a cool story, and so obviously this idea is really relevant, especially in the modern day where we're sending all sorts of personal information flying all over the internet. So part of the day is to learn like how does that even work. Okay, one other real cool real life example is this guy called the Zodiac Killer. I guess I shouldn't call this a cool example, but he's a guy that he was never caught in California, and he wrote a bunch of these messages to the newspapers or the police, just saying all these crazy things, and they broke most of them. But at one point there was two that were never solved, and then like some teachers in California spent a lot of time on it and broke one of the code and figured it out. And then there's one remaining that was never broken, and since the guy was never captured, it was kind of a famous one because people were trying to break it, see if they could find any more clues that help them catch this guy. But they never broke that code, and they never caught this guy called the Zodiac Killer. There's a movie about this one too. Okay, so I just want to do a very, very basic one with you. So this is kind of fun if you want to pause the video and take a couple minutes, see if you can break this code. ZP VBSF DMFWFS. What does that say? Okay, and the answer to this is this was what's called a Caesar cipher, because it was done in the days of Caesar, and it's just shifting the letters down the alphabet. So I think on this one you shift it one back. So like if it's a Z, you shift it back one and get Y. So this first letter here is Y, and then P you shift back and get O. And I tried to line them up down here to make it easier, but I kind of messed it up. I almost did it backwards. You got to take this V and go up here. So I just shifted them down here in red. But it's U, and then B would become A, and then S would become R, and then F would become E. It says U, R, I don't know what D is. D would be a C, M would be an L. Okay, and you get it hopefully at this point, but I think it says you are clever, and sorry for my terrible handwriting there, but maybe I'll type it out here in case you can't see that very good, but it should be you are clever. Okay, and so Caesar, that's what they did early on, is you just shifted it down, and I just did one here, but you could shift down by 5 or 6, or shift up by 5 or 6, and that's the idea. All right, there's a Caesar cipher, and This one is easy to break, especially with computers. And there's some analysis you can do to figure this out. So this was done early on, but eventually people figured out how to break that code. Okay, here's another one I thought you could try to wrap your head around. Okay, and then this one is another really basic one. I think the hint here is like there's not many words that are like this long, so that's kind of a hint. And the key is if you take every other letter, like I'm hacking out every other letter. I don't know if you'll be able to see this very well because I'm kind of scribbling these out. But if you do this and keep going, take out every other letter, you'll get the message that math is a wonderful thing. Right? So, I don't know, kind of interesting. I think it's kind of shows you some interesting skills of like how you might try to break it is, realize that like, there's too many letters for this word or whatever. So that'd be a way to break it. Okay, so certainly you could have ones involving numbers. So this one's kind of tricky, but a lot of these are just effort, right? Like I think when they broke that Zodiac guy, it was just people that spent hours trying to figure it out. And obviously with computers, they're really good at testing things fast. So we're going to try to break some codes with computers here at the end of this lesson. But here's one more for you to try if you want to spend some time giving it a shot. Okay, and so this one's called a substitution cipher is the way that this one is set up. And so it's just, real basic, like 13 is the 13th letter of the alphabet. And so I think it just becomes Mr. And then 18 would be R. 4 would be D. This is my old buddy. I did this back in the middle school, and this was my buddy, Mr. Donay, I think is what this spells out. Alright, and there is your broken method. So, obviously you can do numbers. That one's really super simple. I think I used to do it where I made you subtract the number first or something, but I don't know. So it's really hard to crack without a computer. I guess kind of my message from that one. Okay, so I think what I want to do next here, if I remember right, is to try to program the Caesar cipher and just to try to check every possible one, right? So like, you could shift down 1 down the alphabet, then 2, then 3, and that's really tedious to do it by hand. So I want to see if you could come up with an algorithm for doing this because because it's so tedious. Can we do it with computers? So what would that look like? So again, you can pause the video and try to come up with the algorithm here. Okay, so I think the algorithm makes sense is try. So we're going to do a loop, but we're going to loop for 1 to 25. That's a shift length. And we don't need to shift 26 because that just goes back to the start. So loop for 1 to 25, shift the letters down by I, which will be the 1 to 25 number, right? And then translate the message using the shift. Okay, so shift each letter by whatever, and then translate it, and then check if the message has any common words. Okay, so in this program, basically there's an array of common words, and so after we shift, if we hit any common words, we're going to print if we hit a common word, print out the translated message. All right, because if we hit even one word, we can just print it out, and then if it, it might look like gobbledygook because maybe we just randomly hit a common word, but once we print out, we can look at it and say, oh, hey, that does look like an actual method. All right. Okay, so we're going to write this program that'll do the Caesar cipher, testing all the possible shifts. All right, so if you go here and get this link to starter code, and then you want to find the one that is the Caesar cipher starter. So just grab that one right there and load it into your Eclipse. Okay, and it should look like this. You can see you've got some different encrypted messages here. All right, and then so there's a method that'll decrypt the message, and then it'll print out a dash between them, and then so you got to do it 3 times. So you just got to write this message that'll decrypt these messages. Okay, and I did the alphabet twice, so that like if you get a Y in your shift, so let's say you have a Y in your shift left is 8, you would have to wrap back around the other side. But to make it super simple, I just did it twice so that you don't have to worry about, like if I have to shift Y8, I can just keep going this way and it'll kind of automatically loop it for me. Okay, so kind of the concept is like if we do this by hand, right? Like it's kind of a good way to think of it is like if I've got a shift, let's see an example here. Let's say the message is hi and our shift is 5. Okay, so we would just take this H, find where H is, whatever index this is, and then add 5 to it. Go down 1, 2, 3, 4, 5, and that would be an M. I guess I'm decrypting it here, not encrypting it, but whatever. You hopefully get the idea. Okay, and then the I is right here. Find its location, and then shift down 1, 2, 3, 4, 5 spots there. Okay, so that's the idea, is to like decrypt. We're going to take the letter, find where it is, do index of, and then shift it down. Okay, and we've got to do this for all the possible links. Okay, so if you want to pause the video and try it, you can try it kind of piece by piece, but your code is going to go here. And then, and one other thing that's real helpful here is you've got to do a has common words. So I talked about like once we decrypt it, like once we try shifting it by 1 or 2 or 3, we want to see does it contain any common words. So this is just a Boolean method you could call that has a common words. And basically you want to test the code here to see if it has any of these ones here. So I left this method for you too with the description there. Okay, so I would pause the video and see if you can, fill this in using the comments. All right, and then I'll make a second video here that goes through the answer to this. So give it a shot first. It might be kind of tricky, but give it a shot, and then you can watch that other video.